So in this video we are going to discuss about the remaining factors, which was the binding of the oxygen with the hemoglobin and the liberation or dissociation from the hemoglobin. Alright, so first factor, let me give you the overview. For example, this is the alveoli. Here the oxygen level is high. Alright, here is the oxygen level is high, which means binding of O2 with hemoglobin. Alright, which means it is directly proportional. If the oxygen level will be high, so which means the binding of the oxygen with the hemoglobin will be also high. So when the oxygen will combine with the Hb, which is the hemoglobin, which is a respiratory pigment, it will make a oxyhemoglobin, which is a compound or an unstable compound, because tissues also need the oxygen, so that's why it will break. Alright, so this is the binding of oxygen at alveolar or at lungs level. Alright, because in all the six system, oxygen is more in the alveoli. Alright, and this is occurring in the RBC, because you guys all know 70% of the hemoglobin is in the RBC. So this was the first factor in the we have talking. This is a tissue level, for example, tissue level of any organ. Tissue level. So at tissue level the oxygen is less. Why? Because there are many metabolic activities basically occur. So just because of the metabolic activities occur, so the carbon dioxide basically liberate. Alright, carbon dioxide liberate as what? Liberate as a byproduct. Alright, so the dissociation of the Hb will occur of the oxygen. Alright, so here the oxygen level is less and the carbon dioxide is more. If the carbon dioxide will be more, so there will be what? There will be the dissociation of the oxygen with the hemoglobin. Alright, so here the concentration of oxygen is what? Oxygen is low. When the oxygen is low, which means there will be the liberation of oxygen, it means the dissociation of oxygen. And where the oxygen is more, which means there will be the binding of oxygen with the hemoglobin. Alright, so here the carbon dioxide concentration depend as compared to the tissues. Alright, there is every concentration is different in the tissue level of the carbon dioxide. So we will do what? Here if the carbon dioxide is more, so the oxyhemoglobin will break into the hemoglobin plus oxygen. This will be here it will be the reversible reaction. Alright, which means that if the carbon dioxide will be more, so there will be the binding of the oxygen will be less. Here the oxygen is more, which means that the binding of oxygen will be also more. Here carbon dioxide is less, or carbon dioxide is more, so here the binding of the oxygen will be less. So carbon dioxide from the tissues, carbon dioxide from tissues to what? Tissues to blood capillary, and blood capillary to the alveoli, and from alveoli it will move out through the exhalation. So here we will see that there are some factors in which there is the binding of the oxygen and the dissociation of oxygen is there. Alright, third factor, this was the overview that we have discussed in the previous video. Now I am going to discuss about the next factor, that is the temperature. Alright, if the temperature will increase, so the binding of oxygen will be decreased, which means the dissociation will be occur. Alright, liberation will be more. So which means it is inversely proportional. If the temperature got increased, binding of oxygen with the hemoglobin will get decreased, which means it will facilitate the liberation of the oxygen. Liberation of the oxygen will be high. Alright, so it will generate energy will be generated, which means it will facilitate the liberation of the oxygen. For example, you take the example of the heavy exercise all the metabolic activities. So when the temperature will increase, when metabolic activities will occur, and when the metabolic activities will occur, so the carbon dioxide concentration will get more and the binding of the oxygen will be get less. Alright, so here the liberation of the oxygen will be high. So O2 to be produced to the tissues. Alright, here the hemoglobin will be detached from the oxygen will be liberation. Fourth factor, which is pH. pH is what? pH is the power of hydrogen. Alright, so when the carbonic acid will break into the hydrogen plus in the bicarbonate, and we are going to discuss in the transport of carbon dioxide, don't worry. So when the pH will be decrease, which means in the table the less than 7 there is acidic pH. So when the pH will decrease which means at the acidic level. If it is increased, which means at the alkaline level. So when it is increased, so the hydrogen ion will be produced more, because this is acidic. Hydrogen ion will be produced more, so which means that the binding of oxygen will get less, because hydrogen will move to attach with the amino group of the hemoglobin. So the oxygen cannot bind because hydrogen will be getting bind, so the oxygen binding will be get less. Alright, so the which means of oxygen binding will be getting less, which means the liberation will get more. Alright, now if the pH increase, which means the hydrogen ion will get less. Alright, so which means there is the more binding and the less dissociation. So if at tissue level, if more oxygen is required, so the pH will get less and O2 will liberate more, and that will move toward the oxygen, not oxygen, to the tissues. So this were the some factors you can see here. So this was about today's video.